mathematicians. Today we are going to talk about rhombi and squares. So for a rhombus, they have the same properties of parallelograms. Opposite sides are congruent, opposite sides are parallel, opposite angles are the same, consecutive, add to 180, diagonals bisect each other or cut each other in half. Okay? They are not like rectangles. Their corners are not 90. So a rhombus is like a square on a slant. So you take a square and tilt it sideways. Their corners are not 90 like a rectangle. However, all four sides are the same. Okay. All four sides are congruent, so they all have the same measure. Diagonals are perpendicular. And that upside down T marks perpendicular. What does it mean to be perpendicular? They form 90-degree angles. So when I take a diagonal here, I would have four 90-degree angles in each corner. Lastly, diagonals bisect. What does it mean to bisect? They bisect or cut in half the angles. So if this corner, this bisects, so it cuts it in half. So this angle must equal this angle. Okay? And opposite angles are the same, so that means these are the same over here as each other. So all four of those are the same. And then all four of these would be the same measure as well. Okay. They are not all the same, but the opposite ones are the same. Okay. So more rules about a rhombus, or plural is rhombi. So they're telling us each one of these is a rhombus. Find the missing measures. Right, so JK is 12. JN is 7. Use this to find other pieces. So JM is over here. What do I know about the four sides of a rhombi or a rhombus? They're all the same. So JM must be 12. JL, so this diagonal here. If this piece is 7, what is this piece? 7, so what's the whole thing? 14. MN. MN is this half of this piece here. Now, these pieces are not necessarily the same length. There's nothing about diagonals are congruent this time. Okay? So I can't just say that this piece is 7. That's what we could do on rectangles. That was nice. Can't do that here. So I know this makes a right angle. And yesterday, what did we say we needed to do to find the missing side of a right triangle? Pythagorean theorem. Side squared plus, here's the side I need. So I'm using this triangle here. Side squared plus side squared, the one I don't know, equals diagonal squared. So side squared plus side squared equals the diagonal squared. Go ahead and solve. 7 squared is 49. 12 squared, 144. How do you solve? 144 minus 49. Square root of 95, that piece is about 9.7. Then it asks for MK, which is this whole piece. If this piece is 9.7, what is this piece over here? 9.7. So what is the whole thing? 9.7 times 2, or 19.4. So use the Pythagorean theorem to find the missing side of a right triangle. These pieces must be the same, so the whole thing 19.4. Go ahead and try this next one on your own. Let's see how you did. EF was 23. DF was 40, so each piece must be 20. The whole thing was 40, so each piece was 20. Let's find some missing pieces. GF is a side. What do you know about all sides of a rhombi? They're the same, so this one must be 23. HF, we said the whole thing was 40, so each piece is 20. GH is right here. These make what in the middle? A right angle. So what can I use to find this missing piece? Pythagorean theorem. We already said this one was 23. So the piece I need is that the side or the angle? The side. Side squared plus side squared equals diagonal squared. 20 squared is 400. 23 squared, 529. How do you solve? Subtract 400. X squared equals 129. And lastly, how do you solve? Take the square root of that. X equals about 11.4. So we could use that. This was a right triangle. Now this works only for right triangles, that right angle there. Only if it makes a right angle can we use this. Okay. So this piece is 11.4. Lastly, it asked us for GE, which is all the way across. If this piece is 11.4, what is this piece? 11.4, which makes the whole thing 22.8. Let's take a look at this next one. ZY is 34, so let's start labeling. What else do we know? WY is 38. That's the whole way, so each piece would be 19. And angle ZXY is 34. What do I know this line does to this angle over here? Cuts it in half. So if this one's 34, this one must be 34. That might come in handy later. So let's see what we have here. WZ is a side. What do I know about the sides of a rhombus? They're the same. So if this is 34, all of them are 34. VY. Well, the whole thing was 38, so we cut it in half, so each piece was 19. ZV. I figured we'd have another one of these. What is made right here? What type of angle? 90 degrees. If I have a 90 degrees angle, a right triangle, what can I use to find a missing side? Pythagorean theorem. Side squared plus what next? side squared equals diagonal squared. Type some things in for me. 19 squared is 361. 34 squared how do you solve for x? Subtract 361 on both sides. And how do you solve? How do you get rid of a squared? Square root. X equals about 28.2. This piece here is 28.2. I'm guessing, following the pattern, ZX is going to be the whole way. If this is 28.2, what is this over here? 28.2 and 28.2 make 56.4. Lastly, we have to find some angles. WXZ. WXZ. So this angle here, we already said if one of them is 34, the other is 34 degrees. Move my paper over. Sticky there. WVZ. WVZ. In a rhombus, what do you know about the four angles in the middle? They're all 90, so WVZ must be 90 degrees. ZYW. ZYW. So this big angle here. Well, opposite angles are the same. And if this one's 34, I can also go over here would be 34. 34, 34. So if I look at this angle, I want to look at this half triangle here. It cuts the rhombus in half. What do you know the three angles of a triangle must add up to be? 180. So do I know two of them? And I need to find the third. So I'm looking at this big triangle here. So 180 minus the two little ones I know should give me that angle. And that one is 112 degrees is this big one here. So I found this triangle that split it in half. These ones were both 34, so then subtract from 180. Lastly, X, Y, W. X, Y, W. Sometimes it takes a minute to find the one they're talking. So they just want this one. That is half. Remember, a diagonal bisects. So if I'm looking for this one here, it is half of the 112. So 112 divided by 2 is 56 degrees. So diagonals bisect an angle. So if I know the large one, cut it in half. And there's your information for a rhombus. Nice job, mathematicians.